So in this question, we're told that when a biased six-sided dice is thrown once, the probability that it will land on 4 is 0.65, and we're told that this dice is thrown twice. Amir draws this probability tree diagram, and the diagram is not correct. So if I have a look at the diagram, we can see that on the first throw, the probability it lands on a 4 and doesn't land on a 4, and then similarly on the second throw, having landed on a 4, it either then lands on a 4 again or doesn't land on a 4. And with this information in this tree diagram, we're asked to write down 2 things that are wrong with the probability tree diagram. So especially when it comes to tree diagrams, I feel like a good place to start is going to be looking at what the probabilities sum to. So in each branch, in each kind of section of the tree diagram, on each throw, the probability of it landing on a 4 and not landing on a 4 need to sum to 1, as these are the only 2 outcomes that can happen. The probability of the sum of their probabilities must be 1, as these are the only 2 things that can happen. So if I have a look at the first branch, we have 0.65, which, yes, it says in the question, is the probability it lands on a 4. However, here we have 0.25 that it doesn't land on a 4. Add these together, and we're not going to get a total of 1. We're going to get 0.9. So that's the first thing that is wrong with this diagram. And if I carry on having a look, if we then go over to the other branches, I can see that the probability of it landing on a 4 again should be 0.65, because this is a new throw of the dice. There is a 0.65 probability that it does land on a 4. However, here we have a probability of 0.35, and the 0.65 is here. So these two are swapped. These are the wrong way round. The probability that it lands on a 4, despite it being the second throw, is still the same, and this one should be 0.65. So I can then just kind of put these ideas together and write up my answer. I've now found 2 things that are wrong with the tree diagram. And in the first box, I'm simply going to put that probabilities should always sum to 1. So 0.25 should be 0.35, and it's always a good idea just to kind of give an example of what you mean here. And then secondly, that for the second throw, the probability that this dice lands on a 4 should be 0.65, not 0.35 that it says in the tree diagram above. So that's for basically saying that the 0.35 and 0.65 are reversed. We get a mark for each of these ideas for getting a correct answer for each of the 2 things that are wrong with the diagram. Each one gives us a mark here.